Assalamualaikum and hi. My name is Aina Solehah and today me and my group Aisyah binti Mohammad Isham and Nurul Hannanie binti Abdul Halim will present to you our final year project on a review paper entitled Tellurite Glass. Before that, shout out to our beloved supervisor Miss Mazrini binti Mazlan and our lecturer Sir Muhammad Hafiz bin Muhammad Khalid.
Hi and Assalamualaikum. My name is Aisyah binti Mohammad Isham from UiTM Tapah, student Applied Science. So today I would like to present about abstract and introduction of Tellurite Glass. Let's start. So we will start with abstract. This video provide an information about Tellurite Glass. The aim of this study are to determine the common method that frequently used to produce the Tellurite Glass, to identify the composition of Tellurite Glass, and identify the properties of the Tellurite Glass. The most common method used were melt quenching, thermal analysis, this technique, SRD spectroscopy, TEM spectroscopy, and FTIR spectroscopy. Tellurite glass have been received more attention as scientific and technological interest due to their low melting temperature, good transmission in the visible infrared spectral regions, high refractory index, high dielectric constant, and large order nonlinear stability. This material can be used for optical curve effect. Next, introduction. Glass is a state of matter. It is solid produced by cooling molten material so that the internal arrangement of atom or molecule remain in a disordered state that have similar arrangement in a liquid. There are 7 types of common glass, which are soda lime glass, lead glass, borosilicate glass, aluminosilicate glass, high silica glass, and also tellurite glass. Tellurium oxides is the main component in tellurite glass. Tellurite glass are non-crystalline solid that have a lot of requests in photonics. Tellurite glass become visible composition that can handle a large temperature range. Tellurite glass are characterized as the low melting point and absence of the hygroscopic property, which is limit application of phosphate and borate glass. The most common method that we found is a melt quenching. Melt quenching is the traditional technique of a glass making and includes mixing of ingredients, heating up to a temperature usually higher than 1040 Celsius, and the quenching of the glass melt to obtain a glass free. The first major characterization of the fiber optic properties of Tellurite glass were published in 1994. In 1997, Mori et al. Discovered that it was possible to use ER3 plus doped Tellurite glass fiber for broadband optical amplifier. Further study on Tellurite glass has been undertaken worldwide, powered by growth of the telecom industry. So next, we will continue with methodology and literature review. Thank you.
Hello, Assalamualaikum. My name is Hannanie binti Abdul Halim. I will present to you about Tellurite glass. Then I will continue from my part, there is literature review. Tellurite glasses contain tellurite oxide as their primary component. The glass that being created was translucent and have 3D geometric point examine the system at small interval based on its composition and distribution in the G or S region of the GFR glass forming zone. Tellurite glass has a wide transmission window with a infrared wavelength up to 6 micrometer, significantly lower phonon, the energy of around 700 and a high solubility of rare earth ion. The Tellurite glass was ideal host material for the production of single and high frequency fiber laser. Tellurite glasses are one of the scientific and technically important due to their low melting temperature, strong transmission in visible and infrared spectral region. It also have high refractive index, high dielectric constant, and high third-order nonlinear susceptibility. Next, I will continue for the part methodology. There are 2 methods that we use to make Tellurite glass. The first one is by using melt quenching method. The Tellurite glass with nominal chemical composition in mole percent have 70 tellurium dioxide, 15 barium fluoride, and 15 yttrium trifluoride that being co-doped with an additional total of 5% of ytterbium or erbium 3 ion 5/1 as their outside raw material, 50 grams of powdered tellurium dioxide, 99.99%, barium fluoride with 99%, yttrium trifluoride 99.95%, erbium oxide 99.95%, and ytterbium trioxide 99.95% as the starting material. Powders were vigorously ground with alcohol, dried, and been dried after that. Thus, it been heated to 900 degrees Celsius for melting in electric furnace that been hold for 1 hour. The melting glass was poured into the preheated copper mold to form glass in bulk. Annealed at 350 degrees Celsius for 4 hours, then be cooled to room temperature and is normal to have a parent glass that be named PG hereafter. For the second methodology, that is thermal analysis method, thermal analysis methodology is proposed for the development of a thermal treatment plant for glass ceramic preparation. Glass ceramic were prepared using the PG, undergoing a follow-up heat treatment at 420 degrees Celsius for 2 hours. Nucleation and eventual 530 degrees Celsius for 2 hours or 0.5 hour for crystal growth. The sample of the PG and the ceramic glass were sliced into slices and polished for optical measurement with a thickness of 1.3 mm.
Next, let us continue on results and discussion for this project. Basically, our project have different experimental results. According to figure 1, it is clear that the linear refractive index rises from 2.10 to 2.15 with a rise in niobium pentoxide content from 0.01% to 5 mol% after having considered the concentration of transition metals ion Nb5+ in sequence A. The attachment of niobium pentoxide to the network results in the creation of tellurite asymmetric polyhedron with 1 short, 3 elongated TeO bonds and tellurium trioxide trigonal pyramids with non-binding oxygen. Thus, the increase in the rate of non-bridging oxygen NBO at the expense of bridging oxygen BO raises the refractive index. The calculated refractive indices for the 3 series of glass are greater than the one for fluoride glass, silicate glass, phosphate glass, and near to those used in chalcogenide glass. For figure 2, it shows the result for variation of the average dispersion with niobium pentoxide, neodymium trioxide, and erbium oxide in mole%. According to journal Thermal Properties of Multi-Component Tellurite Glass, the case of prepared tellurite-based glass system, AB numbers, or also known as VD, were located in the range 18.05 until 25.16. For figure 3, it shown a broadly tunable ER3+ or CE3+ co-doped tellurite fiber ring laser with a tuning range of 83 micrometer. However, in tri-doped tellurite glasses, extreme and ultra broadband emission occurs due to the ideal overlapping of the ER3+, ND3+, and PR3+ emission bands in tri-doped TEPN1 tellurite glass, whereas the FWHM is up to 256 nanometer in TEPN2 with 0.1, 0.2, and 0.05 mol% of erbium oxide, praseodymium oxide, and niobium trioxide. Figure 4 shows the XRD pattern for the prepared tellurite glass sample. As you see on the figure, there is a large hump in the XRD pattern between 20 degree and 40 degree with undetectable sharp diffraction peaks, right? Well, actually it describes the long structural disorder characteristic of the amorphous network, which is common of the structural materials of the amorphous state. Besides, the processed tellurite glass thus has a non-crystalline structure. This was proved from the XRD patterns obtained from the 7TeO2.3M2O3 and 7TeO2.3M apostrophe 205 IR spectra that did not show any crystalline form in the samples. In figure 5, a standard amorphous large diffraction pattern was observed for PG, implying the absence of any crystalline species. On the other hand, crystalline structures were observed in glass ceramic with different peaks at 27.6, 32.0, 45.9, 54.4, and 57.1 of 2 theta positions. XRD was used to assess the crystalline phase formed in the samples. Besides, the GC1 became opaque to light while the GC2 remained transparent. This means that the glass ceramic containing of the monocrystal process have been successfully synthesized. The crystal population increased dramatically with the prolongation of the crystallization period. Moreover, it can be seen in the XRD diffraction patterns that the GC1 has very high crystallinity properties, suggesting that the degree of crystallinity in this sample is high. Although in GC2, the amorphous characteristics are much more prominent than the crystalline characteristics, suggesting that the degree of crystallinity for GC2 is very low.
In conclusion, this project proved that Tellurite glass will change in variation of its characterization, composition and properties when used for different experiment and application. Moreover, Tellurite glass is important as it has been used in the latest laser application and sensing devices and which is very useful for living use nowadays. Thus, this research paper had provided more significant information regarding the benefits and uses of Tellurite glass. Thank you for watching.
Lastly, this is the list of our references from others' journal. That's all from us. Thank you.